So we live on Earth, but it's just one of 8 unique worlds orbiting our sun, some much larger, some much smaller than our own planet. From our familiar vantage point, it's easy to forget that we are part of a much larger, more complex cosmic family, with planets that dwarf Earth and others that are mere fractions of its size. Each planet, each moon, each asteroid tells a different story, a tale of fire and ice, of serene beauty and violent storms, of beginnings and maybe endings. These stories are written in the language of physics and chemistry, etched across surfaces of rock and gas, just waiting for us to decipher them. To understand our own home, we must first understand our neighbors. Some, like Jupiter, are over 11 times wider than Earth, while others, like Mercury, are less than half Earth's size. In this video, we're going to embark on a grand tour, a journey through the solar system, exploring worlds both gigantic and tiny compared to Earth. We'll travel together, not in a spaceship of the imagination, but through the lens of scientific discovery, propelled by human curiosity. We'll feel the intense heat radiating from the scorched surface of Mercury, a planet just 38% the diameter of Earth, and shiver in the face of the icy supersonic winds of Neptune, a giant nearly 4 times wider than our planet. We'll witness the swirling, chaotic beauty of Jupiter's storms, on a world so massive it could fit over 1,300 Earths inside, and gaze in awe at the majestic rings of Saturn, a planet more than 9 times Earth's diameter. This isn't just a trip to see other places, it's a voyage to understand our place in the cosmos, among worlds both vast and small. So buckle up, prepare to have your perspective shifted, your sense of scale challenged, and your wonder ignited. We are about to leave the familiar blue and white marble of Earth behind and venture out into the vast, silent expanse that surrounds us. Our journey begins now, as we set a course for the very heart of our solar system, to the sun-blasted sentinel that guards the innermost orbit, Mercury, a world much smaller than Earth. Let's go. Our first stop is Mercury, the smallest planet in our solar system, just about 1/3 the size of Earth. In fact, if Earth were the size of a baseball, Mercury would be closer to the size of a golf ball, and it orbits closest to the sun. Its name comes from the swift Roman messenger god, and for good reason. It zips around our star in just 88 Earth days. From here, the sun would appear more than 3 times larger and 7 times brighter than it does from Earth. This proximity creates a world of brutal extremes. During its long day, surface temperatures can soar to a staggering 800 degrees Fahrenheit, hot enough to melt lead. But without a significant atmosphere to trap that heat, the night side plunges to a frigid minus 290 degrees Fahrenheit. It's a cosmic dance between fire and ice. Look closely at its surface. It's a testament to a violent past, scarred by countless impact craters, much like our own moon. These scars tell a story of billions of years of bombardment from asteroids and comets. But Mercury holds surprises. Despite the blistering heat, deep craters near its poles, perpetually shrouded in shadow, harbor deposits of water ice. Think about that. Frozen water on the planet closest to the sun. It's a powerful reminder that the universe is rarely as simple as it first appears, filled with paradoxes that challenge our expectations and deepen our understanding of how planetary systems work. Leaving Mercury behind, we journey outward to our next destination, Venus. Often called Earth's sister planet, due to its similar size and composition, Venus is almost the same diameter as Earth, about 95% as wide, and roughly 80% of Earth's mass. But this sibling is anything but identical. Shrouded in a thick, unbroken veil of yellowish clouds, Venus hides a truly hellish landscape. Its atmosphere is a toxic brew, composed almost entirely of carbon dioxide with clouds of sulfuric acid. This dense blanket of gas creates a runaway greenhouse effect, trapping heat so effectively that Venus's surface is the hottest in the solar system, a uniform 900 degrees Fahrenheit, even hotter than Mercury. It's hot enough to melt zinc, tin, and lead. If you could stand on its surface, and honestly you wouldn't want to, you would be crushed by an atmospheric pressure more than 90 times that of Earth's. It's the equivalent of being nearly a kilometer deep in our ocean. The sky would be a dim, oppressive orange, and the landscape a panorama of volcanic plains and crushed rock. Soviet landers that bravely touched down here survived for only a couple of hours, before being silenced by the extreme conditions. Venus is a cautionary tale, a stark example of what can happen when a planet's climate feedback loops spiral out of control. It's a vision of a paradise lost. And now, we return home. From the harsh extremes of our neighbors, we arrive at this world, our world, Earth. Earth may seem small in the vastness of space, but it's actually quite remarkable, about 12,742 kilometers, or nearly 8,000 miles in diameter. Look at it. The swirling white clouds, the deep blue of the oceans, the vibrant greens and browns of the continents. This is a world teeming with activity, a planet that is dynamically alive. The key to this vitality is liquid water. Oceans, lakes, rivers, and glaciers cover more than 70% of the surface, creating a global water cycle that drives our weather and sustains every living thing. It's the perfect solvent, the cradle of biology. Our planet is also wrapped in a protective blanket, a multi-layered atmosphere that does more than just provide the oxygen we breathe. It shields us from the sun's most harmful ultraviolet radiation, burns up most incoming meteoroids, and maintains a stable range of temperatures that allows life to flourish. This delicate balance, this perfect combination of water, atmosphere, and a stable orbit in the Goldilocks zone has allowed for an extraordinary experiment to unfold over billions of years, the evolution of life. It's a fragile, interconnected system, a precious jewel in the vastness of space. Even though Earth is just a tiny dot compared to the giants of our solar system, it is the only home we know. So, our next leap takes us to the fourth rock from the Sun, Mars. Known as the red planet, its rusty hue, well, it comes from iron oxide, basically rust, covering its surface. Mars is only about half the size of Earth. Its diameter is roughly 6,800 kilometers, compared to Earth's 12,700 kilometers. In fact, you could fit about 6 Mars planets inside the volume of Earth. For centuries, Mars has totally captured our imagination as a potential abode for life, a world that seems tantalizingly similar to our own. It has polar ice caps that grow and shrink with the seasons, a day that is only slightly longer than ours, and weather patterns, including these giant dust storms that can, engulf the entire planet for weeks. It feels familiar, yet it's profoundly different, a cold desert world with a thin atmosphere. But the most compelling story Mars has to tell is one of water. Check this out. Images from our rovers and orbiters show ancient riverbeds, sprawling deltas, and minerals that could only have formed in the presence of liquid water. The evidence is pretty overwhelming. Billions of years ago, Mars was a much warmer, wetter world, with a thicker atmosphere and possibly shallow seas. So where did all that water go? Some is locked away in the polar caps and underground, but most was likely stripped away into space as the planet lost its magnetic field and its atmosphere thinned. Mars is, honestly, a planet of ghosts. The ghost of a past climate, the ghost of flowing rivers, and perhaps the ghost of an opportunity for life. All right, we now cross a great divide in the solar system, the asteroid belt, and approach the undisputed king of the planets, Jupiter, a true giant whose size is simply staggering compared to Earth. This is a world on a completely different scale. Jupiter is so immense that all the other planets in our solar system could, fit inside it. In fact, Jupiter is over 11 times wider than Earth and more than 1,300 times its volume. It's a gas giant, meaning it has no solid surface to stand on. What we see are just the tops of its endlessly churning clouds, organized into these beautiful colored bands and zones that race around the planet at different speeds. These are driven by powerful jet streams and storms deep within its hydrogen and helium atmosphere. And then there's the Great Red Spot. This swirling crimson oval is a storm, but honestly, calling it just a storm is kind of an understatement. It's an anticyclone, wider than our entire planet, that has been raging for at least 300 years. Imagine a hurricane that lasts for centuries and is bigger than your whole world. Jupiter is a place of immense energy and power, almost like a miniature solar system in its own right, with a faint ring system and dozens of moons, each one a fascinating world of its own. It's a protector, too. Its powerful gravity deflects many comets and asteroids that might otherwise threaten the inner solar system, including Earth. Continuing our outward voyage, we come to what is arguably the most breathtaking sight in our cosmic neighborhood, Saturn, a true giant among planets. Saturn is the second largest planet in our solar system, with a diameter of about 72,000 miles, over 9 times wider than Earth. While other giants have rings, none are as spectacular, as complex, or as famous as these. From a distance, they look solid, like a celestial halo. But as we get closer, we see their true nature. They are not solid at all, but composed of billions of individual particles, ranging in size from tiny dust grains to chunks as large as mountains. These particles are made almost entirely of water ice, with a little bit of rocky material, making them incredibly bright and reflective. The rings are astonishingly thin, in most places only about 30 feet thick, yet they stretch out for over 175,000 miles. Think of a sheet of paper the size of a football field. That's the kind of scale we're talking about. The intricate gaps and divisions within the rings are carved out by the gravitational influence of Saturn's many moons, tiny shepherd moons that patrol the edges of the rings, keeping them in line. Saturn is a world of sublime ethereal beauty, a system where gravity and ice have conspired to create one of the true wonders of the universe, a planet so massive that over 760 Earths could fit inside it. Our journey now takes us into the deep outer solar system, to a world that is truly an oddball. This is Uranus, the first planet discovered with a telescope. At first glance, it appears as a featureless, pale blue-green orb. This serene color comes from methane gas in its upper atmosphere, which absorbs red light and reflects blue and green. But beneath this calm facade lies a planet with a bizarre secret. Unlike every other planet in our solar system, which spin more or less upright like tops, Uranus is tilted on its side, with its axis of rotation pointed almost directly at the Sun. This extreme tilt, likely the result of a cataclysmic collision with an Earth-sized object long ago. Also, Uranus is a true giant, about 4 times wider than Earth and over 14 times more massive. This immense size, combined with its tilt, has profound consequences for its seasons. For a quarter of its long 84-year orbit, one pole is bathed in continuous sunlight, while the other experiences a long, dark polar night. Then, for the next quarter, the situation reverses. This means that each season on Uranus lasts for 21 Earth years. It's a world of extremes, a planet knocked over in its youth that continues to orbit the Sun as if it's rolling along on its side, a testament to the violent and chaotic history of our solar system's formation. We have arrived at the final official stop on our planetary tour, Neptune. This is the most distant planet from the Sun, a world of deep, profound blue. Like Uranus, its color comes from methane, but Neptune's vibrant azure hue is much deeper and more striking, suggesting there's some other unknown compound that contributes to its color. Neptune is a true ice giant, and it's enormous, about 4 times wider than Earth and nearly 17 times as massive. This cold, dark world receives very little heat from the distant Sun, and yet, paradoxically, Neptune is one of the most dynamic and stormy places in the solar system. Despite its distance from any major heat source, Neptune radiates more than twice the energy it receives from the Sun, suggesting it has a powerful internal heat engine. This internal energy drives the fastest winds in the solar system. Here, winds whip through the upper atmosphere at more than 1,200 miles per hour, faster than the speed of sound. These supersonic winds once propelled a massive storm system called the Great Dark Spot, similar to Jupiter's, though it has since vanished. Neptune is a world of mystery and power, a beautiful blue sentinel standing guard at the edge of the planetary realm, vast and mighty compared to our own Earth. We have returned from our journey. We've witnessed the fires of Mercury, a planet just 38% the diameter of Earth, barely larger than our own moon. The toxic veil of Venus, nearly the same size as Earth, and the deserts of Mars, which is only about half as wide as our world. And the colossal storms of the gas giants, Jupiter, more than 11 times wider than Earth, and Saturn, about 9 times our planet's diameter. We've seen 8 worlds, each with its own character, its own history, its own story written in the laws of physics. Each one is a marvel, some far larger, some far smaller than our own. But as we return to the view of our own world, one truth becomes overwhelmingly clear. Of all the places we've been, all the wonders we have seen, only this one, this pale blue dot, is humming with life. Think about the sheer improbability of it all. The precise distance from a stable star, the presence of a protective magnetic field, the abundance of liquid water, the composition of the atmosphere. So many things had to go just right. While we search for life elsewhere, and we must continue to search, we have to confront the possibility that worlds like ours are exceptionally rare. We live on a fragile oasis, a tiny precious island of biology in a vast cosmic ocean that is, as far as we can tell, sterile and indifferent. This perspective doesn't diminish the other worlds. It makes ours infinitely more valuable. Understanding the solar system is ultimately about understanding ourselves and the extraordinary rarity of our home, a planet of moderate size, not the largest nor the smallest, but just right for life. It instills a sense of responsibility, a cosmic duty of stewardship for the only life we know to exist. Our journey through the planets ends here, but our journey to understand and protect this world, a world neither the biggest nor the smallest but uniquely alive, is one that must continue every single day.